The diagram shows triangle PQR inscribed in a circle. PS is a tangent to the circle at P, this very point. Find angle PRQ. Okay, so angle PRQ is this angle here. Okay, for us to solve this, we need to employ some circle theorems. We also need to take note of the fact that this diagram is not drawn to scale. Now, that is a very important information, because that tells us that the line RP, this line is not a diameter. Why we need to take note of that information is because if you consider that a diameter, then you say this is a semicircle, and angle formed in a semicircle equals to 90 degrees. This will become a 90 degrees angle. So you might want to say 90 plus this and this to add up to 180, but that's not appropriate, because this is not a diameter, in as much as it looks like this, but it was not clearly stated in the question. So we know that this is not drawn to scale, and that fact does not hold. Okay, so what can we employ here? We can employ the alternate segment theorem, which says that the angle formed at this very point here is equivalent to the angle formed here. And if that is the situation, it simply means then we can easily solve for this very angle. So let's call this angle y, or any variable, and then now we know that this angle is 73 degrees as well. So we can say that RPS, this is our focus, is equal to angle RQP. This is our focus, reason being because of the alternate segment theorem. From this point, we can say 73 plus 58 plus y all sum up to 180 degrees, because this is what sum of angles in a triangle. So doing that, we can now add 73 to 58 to give us 131 plus y is equal to 180. So take away 131 from both sides. That's collecting like terms. You now have y is equal to 180 minus 131, and that's equal to 49. So y is equal to 49 degrees, which is this angle here, and that was what we are asked to solve for, angle PRQ.